I'm Simon Hettrick, the Deputy Director of the Software Sustainability Institute, and welcome to our panel today, which is all about whether we have the right tools for research. We have a number of fantastic experts across a broad range of technologies. I'm really happy that you could all join us today. We've got everything from spreadsheets to right through to the tools that we're talking about, taking BU beyond the spreadsheet, which is exactly the focus of this entire research software camp. I'll get to the experts in a minute, but I just want to reiterate what Alex said, that we won't be taking questions from the floor. We'll be using Slido, so please do post your questions there and vote on the ones that you want to see asked. As far as I can, I will be following the voting on which questions to ask the panelists. So we have 9 panelists today, and only an hour into which to fit all of their brain power, which is going to be a difficult job. So I'm going to start off by introducing them very quickly, and I think we'll go straight to the questions at that point. So we have Yanni Bellini-Sabene, who's a tenured researcher at the National Institute of Agricultural Technology in Argentina. She's a trainer and instructor for carpentries and an RStudio certified instructor. We have Mike Croucher. He's the customer success engineer at MathWorks, where he works with researchers and educators on many different aspects of research computing. And his interests center around research software engineering, HPC, and cloud computing. We have Lucy Huggins, who is an historian of 18th century marginalized communities in England. She's been doing a defense of spreadsheets for us, which has been really interesting to read. And she has a particular focus on experience, identity, and economies of makeshift. Lucy's work focuses on the links between poverty and theft in 18th century London. We have Peter Inglesby. He's a software engineer with the Data Lab at Oxford University, where he's part of the team that built OpenSafely, a highly secure, transparent, open source software platform for analysis of electronic health records. Lucia Mikkelin, who is the training manager at the Center for Data, Culture and Society. Her main responsibilities involve planning, designing, and coordinating a comprehensive digital research methods training program, so perfectly suited to the panel today. Moore Rubenstein is a data strategist with a decade of experience in using data in the charity sector. She has led data culture work at Parkinson's UK, 360 Giving, and the Open Knowledge Foundation. We have Clive Sevier, who's CSO at Filament, which is a new online workspace for data analysis and reporting. He's also a professor in the Department of Engineering at the University of Oxford. Jack Williams, who is a senior researcher at Microsoft, working as part of the Calc Intelligence team. Jack's research focuses on infusing spreadsheets with programming language technology, including topics such as units of measure, logic reuse, and bidirectional editing. And finally, we have Katie Walterston-Croft, who is an assistant professor in bioinformatics at the Leiden Institute of Advanced Computer Science. Her work is on fair data and knowledge integration in the life sciences. She was involved with the development of the right field semantic annotation tool, which I'm sure we'll hear more about today. So first of all, thank you again to all of our panelists for joining us today. And I think we should get straight to the questions. And as luck would have it, the top one is a nice broad question to get us started. So we've been asked, should I be thinking of moving from using spreadsheets? I don't have the confidence to learn to code. And I'm sorry to pick on you, first of all, Lucy, but you did do a defense of spreadsheets, so I think maybe we could turn to you for that first question.
Hi everybody, thank you. I think it's a bit of a going first, hot water. Yeah. I don't code, so I might not be the best person to ask, but I certainly think it depends on what you want to do. If you want to do some, you know, for me, as I don't know if you've watched my presentation, but for me, it's that iterative data entry process that really sort of builds my research. So if that's the kind of thing you're doing, then perhaps spreadsheets will suit you. But I think that really depends on what kind of research you're doing and what you want to do.
Yes, so I guess whether you need to, do you even need to move away from spreadsheets is the starting point here. I think there is a lot of pressure on people to move towards different methods maybe, but I guess that's the question you need to ask first.
Yeah, I mean, I always feel a bit, you know, people say, oh, you know, your data, and I really usually just use Excel, and it just works for me. It's what I need. I don't feel a need. Well, I'd like to code, but I don't feel a need to for my research.
But I think we need to hear a follow-up from somebody who is coding. So maybe we could move to Peter for a view here.
Hi, so I'm a professional programmer, and I work in a research context. I've been coding for quite a long time, and I love it and I hate it. I think there are sort of two parts to this question. One is do I need to use anything else? And whenever people ask me, should I learn Python for this problem? Or should I use another language, or should I use a spreadsheet? I think one of the biggest factors in making a decision about what tools you used is how familiar am I with the tool, how much expertise is there around me that I can draw on. And if you are an Excel whiz, if you're working in a team where there's a lot of spreadsheet expertise, then that's a really sort of big sort of push in that direction. Now, the other part of the question was about confidence, and I'm sure we'll talk about learning to code in other questions. I think all I'd say is that it's difficult, but it's like any other skill or sort of any other skill you have, like learning a foreign language or learning to cook or learning to drive. The more you do, the more you practice, the less scary it becomes. And in particular, when I've done Python training in the past, I always encourage people to try and break their code so that they can understand how things break, and so that when things do break, they understand what their error messages mean and how they can fix them. It's just a couple of thoughts.
Thank you. So I like this idea as well. It depends on the expertise you can draw on that, but let's move to Lucia next.
Hi, yes, it's just like, I think the best analogy I ever seen is from the Programming Historian website. I don't know, many of you are familiar with it, but they defined the difference between coding and non-coding as going to the supermarket and getting the shepherd pie from Tesco, that it can be really good and it can be all you need for making a good meal out of it, or learning how to cook. So learning how to deal with a small ingredient and how to tailor and really like the breaking it down to the small little detail of things. And there is written anywhere that you have to cook anything from scratch. Like, I'm Italian, so I do cook everything from scratch, but like there is not written anywhere that you have to start from scratch ingredient every single time. And it's the same with coding, like depending on what you need, you may need go back and start from scratch, or the ready to go solution may be all you need. And I guess like in the research context, time, it's really important. So it will all depending on your on time. Like do you have enough time to get to the point where the pre-made solution is not better than whatever you're going to be able to produce in that amount of time. So yeah, sorry, it's just like that was a very good analogy that I read, and I think it's kind of defined very well the need or not need of coding.
I have to say, I agree with using shepherd's pie in more metaphors for how to learn to code. But so what about this time issue is a very interesting one, and maybe we could pick that up within as well, in that it takes an awful lot of time to learn to code, but when you get there, you can save a lot of time, but you have to front load that effort. Katie, can we turn to you next?
Yeah, so I was thinking, is it really either or? So it depends what you're using the spreadsheet for. A lot of people in the life sciences use spreadsheets just simply as a tabular data format to share their data in. And there's no reason why you can't continue to do that, even if you're writing code to then do analyses of the data within the spreadsheets. And then the spreadsheet is just a very handy way of sending that data to other people. and things like this. So I'm not sure you have to choose. The other thing you should probably think about is there not an alternative choice somewhere in between? If you don't have time to learn a programming language, are there tools that have been configured for you that you don't have to actually learn to code to use? So yeah, in bioinformatics, some people build tools, some people use tools, and both types of people are doing research, and it really just depends on the time that you have to put in and what you're actually doing with your data as well. So again, it's about drawing on the expertise around you, drawing on the resources that you have around you, and using the best tool for the best, well, for the right job at the right time.
I think with this building on the tools as well, it'd be interesting to hear from Clive next, because obviously that's exactly what they've done. Oh, and you're on mute, Clive. We did say it was a problem.
I'm sorry, I had to be the first person. So I just a few things at that risk of repeating things that people have said already. So I mean, spreadsheets are great, and you know, Excel is an immensely powerful tool. It's an incredible tool. And I think a lot of people say this, you know, spreadsheets are very much data first. It's a place where you see your data, and often the calculations are behind that, whereas coding is often calculation first. You know, the calculations that you're performing are more visible, and of course you can display data, but the data tend to be less visible. And there are risks in spreadsheets, and there are risks of mistakes, because you're operating on the data in the same spreadsheet as the data are stored. Which does run the risk of mistakes. And with respect to Excel, the graphics are not that great. It doesn't produce the best graphs. There are better ways of doing that. What I would say to the person who asked the question, though, is this: they say that you're not very confident to learn coding, but there's nothing to be afraid of. Learning coding, you cannot do anything wrong. Your code might not run, but you can't do any damage by running your code. And so you've got to start with something you're interested in and that you really want to see the output of, and start with something simple. And you can get some quite easy wins doing data analysis. You can load your CSV files, you can do some data analysis, and you can get easy wins that then give you confidence and allow you to build up. Now, one of the problems, now I'm going to plug Filament a little bit. So one of the problems that we found with coding, and we're interested especially in coding in Python, is that there's quite a high barrier to entry. When we're teaching students, they struggle actually to install the required software on the computers. They struggle to get started. It can be quite intimidating. Somebody says, oh, go to GitHub and get this code. And they're like, what is this GitHub craziness? How do I do this? And so this is, you know, there's a lot of things here that are putting barriers to entry that are putting people off. And so what we tried to create in Filament, and I think we're succeeding, is really an online coding platform where you can go in. It's a notebook format, which it combines written text and executable code. But you can go in and you can start coding straight away. We could send you a log on. You can set up your account, and 2 seconds later you're writing code. And so we're hoping to use this to break down some of those barriers. I'll stop plugging Filament now, because it's not the only reason we're here.
Thank you. So that's interesting about this element of confidence as well, which is obviously part of the question at the same time. Now, when looking to move away from a spreadsheet, you're often looking to what other people are using, and a lot of people are using Matlab, and certainly were in my day of doing PhD. So Mike, maybe you'd like to chip in on that.
Yeah, hi. So I think over the years at MathWorks, we've worked with a lot of people in academia, but also in industry, where they had in all kinds of organizations, they had very Excel based workflows. And by moving to something that was more code based, you save an awful lot of time, and you save a lot of mistakes and so on and so forth. And you know, we've got various case studies, certainly internally. I'm going to try and see if we can find some external case studies we can share, where organizations have said that by making this transition from an Excel-based workflow to a coding-based workflow, you know, it can save time and money. But I think that within academia, certainly, I was in the research software engineering movement for a long time. And I think that we can be guilty of saying, hey, the solution to all of your troubles is to learn to code. And you know, most of the research software engineers have been coding for a long time. And I think that when somebody says, hey, I've got a problem that might be able to be solved with coding, and I'm currently using Excel spreadsheets, and then we say, you can use coding to solve that, we suddenly have two problems. You know, it's you now have to go away and learn how to code, and sometimes you can be there for a long time before you actually start being productive. And you might not even be sure on the outset if it's going to be worth it. Is your current workflow going to be improved in any way? And I think that what can often be helpful is actually just speaking to somebody and saying, this is my current workflow. Is it worth switching to Python, Matlab? Who cares what the tool is? Well, I care, but you know what I'm saying. And having that discussion first, and having an open and honest, frank consultation, if you like, can actually help you decide whether or not it's worth taking the plunge. And then making sure that you're in an environment where you can be helped every step of the way. Can you be productive from the very first day? Or do you have to spend 2 months learning to code before you can actually start even being as good as you were in just a pure Excel environment? Yeah, I think that's what I've got to say for now. So yeah.
Thank you. And I think we'll hear from Yanni and then move on to the next question. It'd be good to hear from another coder before we move on. Yanni.
Yeah, just to add to what everyone says before, that I agree that you have to see which is the problem you are trying to solve. If you already can solve with your tools, I will add something about to learn to code. First, I hope you are not working in isolation. You probably are part of a team. So perhaps choose the tool has to do with your team and how you are working. You are trying to add some new tool to your team. Again, talk with them to see how this new tool can go in the pipeline. And I represent in the R language. And I think that one of the best features of the language have is the community. So I love R because I have a lot of help when I have to learn or to teach or to solve something in R. So the confidence is also come when you find a space, a place where you can make mistakes, make the questions that you say, oh, come on, I'm going to ask this. People is going to think that I don't know anything, but you can do it, that kind of question that we all here did sometimes. Yeah, we don't born learning how to code, and we go through all these steps. And if I learn how to code, every single human being can learn how to code. But you need this space where you feel good making these questions and making these mistakes, and someone's going to take you in your hand and walk with you through this until you feel confident enough to walk by yourself. I think Our Ladies is a place where you can find this kind of help. Carpentries is another community that can help you with this. And the art community in general is pretty generous with the knowledge and a pretty nice place to learn.
Thank you. So I think this point of the community and the level of support that you are given, the people around you who know more than you do about using this new tool has come up across a number of your answers. So I think maybe, although I want to get to the question about how do you choose which tool to use, and I realize we've got a lot of people representing tools here, so that could be a bit of a scrap. But I think so. Let's come back to that question. But first of all, to go to the next question, which is, do universities give researchers enough help in learning to code? That's possibly a slightly politically written. Maybe it should be more, do researchers have access to enough help learning to code within a university? And I wonder if anybody would like to go first on that one. So we have Mike.
So I think I can speak to this from two different points of view. First, when I was running a research software engineering group within a university, a huge part of the work that we did was doing exactly that, supporting researchers and giving them access to more training and the constant feedback and so on. And I see that that's happening more and more around the country. Wherever there's a research software engineering group set up, that tends to be part of the features that they offer. And then this is in addition to what tends to be offered by IT services, their research computing departments, high performance computing groups, and so on. They've also helped giving this kind of help. And individual academics themselves teaching, many disciplines. There'll be some sort of a introduction to programming for engineering or ecology or whatever. So there's an awful lot, I think, at the university level. Could there be more? Always. There's, people could always do with a little bit more help. Just to plug the MathWorks here as well, we will also offer anybody that's using any of our tools. We've got free training, and you can reach out to when most universities in the UK, for example, and indeed in the world, have got a Matlab site license, and you can reach out to technical support as well as the Matlab community. You can actually contact the organization and can speak to people like me. It'll help you out and so on. So I think that there's an awful lot of help there from various communities, and people in the Python and R communities will have similar levels of support. There could always be a bit more, but the question is how to fund it. And that was certainly what I found difficult when I was running a research software engineering group, because you could always say the direct research stuff that you were doing was funded from grants, and so that had a very definite line between the stuff you were outputting and the money coming in. The other stuff, providing training, software carpentry, that kind of thing, very rarely had funding, and it was almost like done as a pro bono thing and in our spare time or whatever, and was much more difficult to justify from a bottom line point of view. And that was very frustrating, because I know that I would have liked to have done a lot more when I was in that role, but just simply didn't have the money. So yeah, I think that's what I've got to say about that.
So we should definitely come back to this issue of how training is funded, because that's really interesting and really important for broadening training. But I'd really like to hear Moore's views first, please.
Hi. So as someone who have studied this, I studied code in university twice. I've seen people coming out of university studying code and learning and trained, and then they come to the real world, they need to solve problems, and they realize that they're hitting a lot of other stuff that they wouldn't hit in class, right? I see that Peter is nodding, because in class, all of your data sets are clean, and you get hints from your basically tutor, and someone is checking your code all the time, and sometimes no one tells you that the Stack Overflow exists, and that basically you're not supposed to create all of your code from scratch. Like, you can literally find it all over the internet. So I think there needs to be training, and there's also needs to be training to specific groups that will not be able to get this training if they wouldn't get it, let's say, in university. And there should be like groups to help, but I think there's also should be a mindset that students and academics needs to actually throw themselves into the work in order to get there. And maybe there needs to be community of practice that help review, like keep telling people it's fine that you suck, like here is other resources that you can go and do, because this is when I find that people are coming into real world research that they're getting stuck, because they learned X amount in training and then they don't understand how the real world of coding is working. And I think a lot of people, specifically women or people of color, are getting stuck in that because they think that they need to know everything and it needs to be there because this is how it looks in the training. And it's definitely not. So maybe we also need to look how we make our training more hands-on and less about here is a clean data set that you can come from beginning. And then I think it will make a lot of people feel less stressed about it as well. So maybe that's also something that we need to think forward. But again, I'm not working in academia now. This is what I'm seeing for people who learned it in academia and coming to my team.
Yeah, that's a really interesting point. Especially, I think Stack Overflow should be cited on a lot more papers because it's contributed a hell of a lot to research. And certainly that difference between the clean ways that you're taught to code when you're in the class and the first thing that happens when you actually try to do it in the real world it's a huge and quite important difference. I think Oh, sorry, more.
No, I just said that I've done a reflection with one of our apprentices. We have an apprentice at Parkinson's UK with data, and his first thing was like, oh, I never actually seen a non-clean data set before. This was the biggest like hurdle that I had. So just like the thing that came from him was like a big sign for me that maybe we need to make data and coding a bit more dirty when we train people. So yeah.
I think so, and certainly things such as the various groups set up around R that Yanni was talking about earlier on is really important, useful community that you can ask questions to. But Lucia having this tie-in with data, culture, and society, now that sounds like you might be somebody who knows about how to support these people.
Yeah, I was going to say, like, I came from a humanities background. Like my degree was in archaeology, and so was my PhD. So I came from the other side of the barrier, and I can see that, like, at least in that sector, there are two very different situations. Like there are schools like social sciences, psychology, that got quite a lot of this training already within the university courses, because it's kind of a long-term method for them, and so they somehow seems more similar to what it happens in other colleges. And there are other schools like mine in which you basically learn by yourself. Like that's what I did. Like I sit down and I decided that I needed to learn to how to code in R for my research because I wanted to do statistical analysis, and I sit down and I learned. And here is when also come a big difference between big university and small university, because as you said, I'm now the training manager for the CDCS that is exactly doing that. So the remit of the CDCS is support data-driven and digital research across the college. And although I felt very lucky about being in there, I do recognize that this is a position of privileges, because Edinburgh is such a big university that can have a center like that. And I'm not that sure that like that's possible across other type of universities. So I guess I don't have an answer on how to fix that across all university. I guess like for big university, having centers supporting these kind of things, it's good, but again, it's not a doable solution for any type of university.
Yes, it'd be interesting to see how the universities cope with providing that kind of service. Clive.
So I'm going to be careful here because I work for a university, but I think that one of the problems we have teaching coding is that and this touches on what people have said already, there's a tendency to have a coding course. You know, they learn mechanical engineering, they learn fluid mechanics, they do coding, and they learn to solve fairly well prescribed problems, as you said, as has already been mentioned, with clean data sets, normally closed problems that we know are solvable because the tutor's done it already, and that's been set up to really turn the handle on various skills. What we should be doing is embedding coding in all other parts of the course. So when they're doing dynamics, they have their calculator and paper, and we should be setting them problems that require them to code and require them to think about how to use code to solve those problems. And there may be many different ways to do it. It's very unconstrained. And that's really where they can cut their teeth and learn to use code to solve problems and solve problems in the code that they're actually writing. But I don't think we do enough of that.
Yanni.
Yeah, just to add what Clive just say, I'm not entirely agree about to teach a content and code with the content, because the cognitive load for the students can be really hard. I teach a lot with statisticians, so I always say I don't want to teach statistics and to code at the same time, because they are too complex content together. So I will teach them how to code, and then you teach statistics, and in an advanced course, we use the two tools together. But it's really hard for people to learn these two scary things, because when you say statistics, at least in my culture, is, oh God, that is hard. And you say to code, and people say, oh no. So it's like I bringing you to a nightmare, but I want you to stay here. So we need to find how to teach these two things in an appeal way. I mean, when I teach to even my co-workers, I start with a report. They can parametricize and they can finish in a Word. So suddenly they see that they can spend more time doing their report that they have to do every month, for example. So we see this in the class 1. So they stay for the rest of the training because they see that this is going to be useful for them. So they're willing to go through this mountain and learn. But if I teach this to code and to do another thing at the same time, it's too much.
We come back once again to this activation energy you have to get beyond to learn to code. Mike.
Yeah, I agree with Yanni. It's difficult to teach two things simultaneously. But one thing that I have seen used effectively, although I think it's very difficult to do it effectively, is when you do use aspects of programming when you're teaching other subjects, but you almost have the programming, you might have like a live script or a Jupyter notebook or whatever, and it'll have some code in and it'll illustrate a concept in statistics or mechanics or whatever, and you can attach some sliders to that. And some of the students might say, hey, what's going on with all of that code? And you could say, don't worry about the code. That's just helping us illustrate this. And sometimes I kind of think that just by always having it there in the background, it slowly starts to lose some of its fear. It's so that when they start to learn to code in anger, like, oh, I've seen this around everywhere. It's nothing to be scared of. It's, it's all over the place. I've always seen it. And most of the time it just works and you can put your hand in and twist and maybe you break it, but nobody dies. It's all fine. And so I have seen some courses have managed to do this where, they use computation to illustrate all kinds of things without having to focus too much on the code as a way of easing people gently into seeing it. I'm trying to think of, there's a certain phrase that I'm trying to reach for that I'm not managing to get. Aversion, not aversion therapy, the opposite. When you keep showing somebody something scary, and after a while they're like, you know what, there's nothing to be scared of there, because I keep doing it. So yeah.
That's okay. So I thought that was aversion therapy, but demystifying it maybe would be the way to take this. So I'd love to hear from you next, Jack, because obviously Microsoft, purveyor of like the main spreadsheet platform, but also of a load of technologies that are taking people beyond the spreadsheet, and you invest a lot in training researchers as well. So yeah, I'd love to hear your views.
Yeah. So one of the things that I wanted to sort of unpick was, there's the resources and then there's the culture. Someone in the chat mentioned the kind of culture around these things. And I think that's really important. And also unpicking sort of the ability to code and just solve problems with code, and then the ability to use that to do sort of robust research. So for instance, in my background, I was doing CS and research around CS, and I had to use programming to run experiments and this kind of thing. And all of the people around me were capable programmers who can solve the problems. But when it came to actually producing robust research that sort of produced data sets, did experiments, that was very much sort of outside the comfort zone. There weren't that many resources to understand how to really set up the infrastructure to do that. And also even in the community, there's culture of it being mandatory to have sort of robust coding and these kinds of things sort of wasn't really there. So I would say, yeah, even if there are resources, and often in my experience there were, the culture of saying we have to address coding in this sort of way wasn't always aligned as the sort of motivations. And yeah, and then also just the distinguishing the ability to sort of code to solve a problem and then being able to sort of apply that in a scientific way. I think that's kind of an important distinction. And I think even in the kind of core computer science academic areas, the sort of the latter part of applying programming scientifically is perhaps not well understood.
So I think so this might be a useful time whilst you're talking, Jack, to move on to the next question, because I know you have an interest in this area, which is, can spreadsheet analysis be reproducible, and what can people do to conduct reproducible spreadsheet analysis?
Yes, I think it can be, although the way sort of spreadsheets have been built over time sort of makes it hard to do that, which I think is perhaps why people get that sort of impression. So it was mentioned earlier on that part of the aspect of spreadsheets that is in many ways great, but also can be a source of problems, is that it's data first, and you have the data and your sort of programs very much together, and they're hard to separate. And that makes things, I think, inherently quite hard to reproduce, because your algorithm and the data are exactly sort of together. And then I guess, yeah, sort of one thing to plug is Excel now has this Lambda, which is just a function that you can add to a spreadsheet. And I think that makes a huge improvement in the ability to sort of do reproducible analyses in spreadsheets, because previously part of the problem is you were doing analysis and it was tied to the data. And so if you wanted to reapply that somewhere else, that would be very, very hard. But now I think, well, hopefully you'll be able to build sort of algorithms that are completely disjoint from your data, but then ultimately you can sort of pair them together. And then another thing I would just add is, in terms of reproducibility, it's not always the tool that is to blame, I think. So another, I guess, common research tool is sort of Jupyter notebooks, and I think they also have problems with reproducibility, and it's perhaps sort of how you approach the problem as much as sort of the tool itself. But I think tools can nudge you to do things the wrong way. But I think, yeah, certainly in the future, I think spreadsheets will become far more easy to turn into components.
I think this is interesting because obviously we've been talking a lot so far about learning to code, the support you get for code, but actually if we could make spreadsheets reproducible, then we would be sorting out one of the major problems with their use in research more.
So I want to say two things. One is that everything that you want to be reproducible needs to be documented. Stuff that we don't do really good in code is document, or teach how to document. This is where I think, by the way, we have a really big blind spot about telling people that, yes, you've written a code, now please document what you've done in it. Because if you haven't written it and someone else wants to reproduce it, or even yourself because you wrote it in a late night and you forgot what you've done, then it's not going to be reproducible. And the culture of no one really likes to document. I have only one person in my team who is amazing, he's a saint, but he's the only one who's documenting everything, and he's like, no one else, basically everyone is building on him to document what they've done. So I think we need to remember that as a really big thing. So even if you have this beautiful Jupyter notebook and you haven't used text in it to say what you've done, collapsed. But the second thing that I wanted to say is that I'm not using Microsoft anymore in my work. I'm actually using Google Spreadsheets, and I'm noticing that because it has history, I can actually sometimes see what I've done. And then I'm like, and then I save my history in a version. Yet again, I will prefer to do a piece of code if I knew like what did I need to reproduce something over and over again. But in history, still, people still use Excel to do, or a spreadsheet or any other thing, to do processes for not for hundreds of years, but like for hundreds of hours. Like I still know in my organization, like people have like this nice Word document that they wrote what they need to do on a spreadsheet. So it can be done, just need to be really careful and really thoughtful. And just remember that if you putting stuff manually, you are more prone to mistakes than if you've done it automatically as well. But just, yeah, you just need to remember all of this into account and take it when you work on it. So it's not gonna only take coding, add like at least an hour to say what you've done on it if it's a really big, complicated code. But that's for me.
Yes, thank you. I think that the time for documentation is just as important as having the skills for documentation, basically. So Katie.
Yeah, so I just want to follow on from some of the things that Mo said. So the spreadsheet in and of itself it depends what you do with it, whether it's going to be reproducible or not. But in our case with Writefield, we use the spreadsheet as a template to generate standardized representations of data sets. And we use embedded semantics to enrich the metadata in these data sets. And so the spreadsheet becomes quite an important piece of the reproducibility of the experiment. But it's not about the analysis of the data, it's about capturing everything the scientists did. And so it's about lowering the barrier to making sure that we capture what you have done. And you'd capture that in a very standardized way using common vocabularies and common ontologies. So then it becomes a tool for reproducibility.
Oh, sorry, I think you cut out at the end for me.
I'm sorry, was that, can you hear me now?
You're very quiet.
Okay.
that might be something to play with whilst we move to Peter to hear from him.
Thank you. I just like to pick up on a point that Jack made about notebooks. Jupyter notebooks in Python are a tool for interacting with code and data in a different way to how I first learned to program from the command line. And I think notebooks are an excellent tool for exploring. They're not necessarily such a useful tool for sort of shipping finished code. And I think in all sorts of walks of life, in research or in producing production software or doing maths or learning a piece of music, you need to sort of differentiate between the first stage where you're exploring and trying things out, and there the audience is you, and then the second stage where the audience is the people you're sharing the work with, and that's where you have to perhaps go back and write things differently and show you're working in a different way. And I've often seen bits of Python code from researchers where they've done the first bit and they've done the first bit very well, but they haven't then done the work to make sure that other people can understand what they've done. And I think that's a crucial part of reproducibility. And I don't see any reason why you can't do that with a spreadsheet.
Yes, I agree. This is a subject I would like to stay on for some time, but I think we better move off because there's a couple of questions. Unless, Mike, do you want to add something just quickly there?
Yeah, really quickly. I think that the main point is that one step towards making these things reproducible is simply to make them available. That's it. Because very often it was the case of we did an analysis in Excel and here's the result. Fine. Where's that spreadsheet? Where is it? You didn't publish it. You didn't put it out anywhere. Just make them available. It would be a great first step.
Yes, yeah, publish it first, preferably with a DOI, and cite that from that point onwards. So I agree completely, but I think we really do have to move on because there is one question which is very well aligned with the subject of this panel, which is how do I choose which language or tool to use in the future? So if we're going to move beyond the spreadsheet, what are we going to move to? I wonder if anybody would like to pick up that question first. So Peter.
Can I do a sales pitch for Python?
Yes, but why not? Why not?
Okay, so Python is a general purpose programming language. It's not a modern programming language these days. It's about 30 years old, and that surprises people sometimes. But it's probably the most widely used language, certainly in academia. And I don't think it's the best language for any one thing. I think if you want to do really sort of resource intensive stuff, there are other languages that are better at that. If you want to do stuff for the web, there are other languages that are better for that. If you want to do, I don't know, like create a mobile phone application to gather data for your research, there are other languages which are probably better for that. but I think it might be the second best language for most things, and that might make it the sort of best language overall. So you can't make an interactive website out of an Excel spreadsheet. It's pretty hard to make an interactive website out of an R script, although there are things you can do in to share data with R, obviously. But anything you want to do with a computer, you can do with Python. And so if you've got no other considerations, and I mentioned it earlier that it's really important to lean on the expertise in your team, but all other things being equal, I don't think you'll go wrong choosing Python.
The second best for most things, jack of all trades language. I like that approach, but I fear that we might hear from one of the other big languages being used in academia now, Yanni.
Yeah, I think that I will say the same, that when we start, so you need to choose the best tool for the work. And even when I here representing R, I code in R and code in Python, and I use a spreadsheet in my research. So for example, I work with weather radar data, and we have a lot of good libraries in Python that I don't have in R. So I choose to work on that language for that kind of work. And then for everything that has to do with stats and analysis and visualization, I'm going to say that I still doesn't find anything as good at in other language than R. And again, as Peter say, what your team are using, what are you profession, what you are working with. If they are using more Python, well, you are going to find more help there. But if they're using more R, you are going to help more people that help you, more samples of code. As previously say, more of the developers, we are very good to Google code, to copy, paste, and change for us. So you're not going to be coding from scratch. So if people in your profession use X language, well, probably you are going to learn that one. So again, the tool for the work, what your team knows, what your community use, and it's good to know more than one too. Actually, it's nice.
I think it's an interesting problem there, isn't it? Because if you go against the tool that is being used by the rest of the group, you're going to have to be a particularly good arguer. So I find that is very difficult. So learning multiple tools, but obviously we've been talking about the cognitive load of learning one, but I think that does go down as you learn more languages, because you've got the general concepts and it does get easier. I say that knowing that I can barely script in one language, never mind two. So I'll move on to more.
I wrote in the chat earlier that one of the also options that people can have before diving into Python or R, which are both lovely, is also to learn a bit of SQL, and like that can help you to understand a lot of stuff. And in my presentation yesterday, Google Spreadsheet actually allows you to have like a whole formula in SQL. Then you can do like fabulous stuff without having your own SQL server, but like these are one step in. And also something to think about when doing tools that are not specifically languages is that you need to think what are the problems that you're going to hit with each tool. So for example, if you have a mega data set, which is one of the questions in this slide, like a spreadsheet will not upload like really well if it's a mega data set, and you'll have to go and clean it somewhere else. So you also need to think how much data you collected, where is the safest to put it, where is the safest to analyze it, etc. I'm going to put in the chat a link to Tim Harford speaking, for example, what happened when government used like old version of Excel instead of using a CSV, because we're speaking here about spreadsheet and Excel, but CSV is also something that needs to be used. So I think people need also to educate themselves what is the limitations of each tool that they want to use. So instead of solutionizing and say, oh, I'll just do it in a spreadsheet because it's the easier thing, is it actually going to show you all the data without losing rows, like happened to the British government when they tried to basically do trace and track and they lost, what was it, 500,000 lines? So yeah, also something to just think when learning about tool is like how much data you're going to have in your research.
It's a frequently sobering moment when you realize just what spreadsheets are used to control sometimes. And the track and trace one was a very good example of that. I think, Jack.
Yeah, so I think sort of following on, just wanted to highlight that tools aren't just the programming languages, they're kind of the other things. And sort of when you think about how do I use tools in my workflow to sort of improve or automate something, the thing that you may need to automate may not be sort of a programming. And so I just sort of wanted to call out, there's other things like version control as a tool, or sort of a different way to like write the code if you've already got started, or the ability to use cloud resources to host data sets and that kind of thing. So I don't have recommendations for any particular one to use, but just sort of when thinking about how can I sort of improve my workflow or my research, it's not just a case of writing a program to do something, because quite often that program might need to be hosted somewhere, or you want to host a data set and give it to other people. And so I just wanted to I guess re-highlight the sort of broad definition of tools and the kind of things that could be useful to people.
Very good point. There's a broad range of tools when you start getting, especially when you start getting into coding, that you will have to become au fait with. And that brings us back again, I think, to our culture question, that you can't learn all of these things yourself. Mike.
Yeah, so obviously I'm hugely biased here. I work for the MathWorks. I'm going to say use Matlab. It's a fantastic tool. But I think that whatever language that you use, also do think about, what else are you getting other than the language? Is more than just a language, as a whole ecosystem. To perhaps do a little bit of research and find out in your particular domain, once you get past the basics, are the advanced stuff going to be there for you? How will the tool that you choose interact with all of the other stuff? Just because you've decided to move on, for example, from spreadsheets, the rest of your group might not. So you might need to make sure that you can build tools that interact fully with spreadsheets, so that, for example, your PI can still use what you're using, and so on. Just putting it out there, Matlab and the associated toolboxes can help you with all of that. And as well, if you choose C++ or Python or whatever, then Matlab plays very nicely with all of those. So I'm going to put Matlab out there as something that's been widely used for a very long time. If you were to look at some of the APIs of other languages, you'd say, they look familiar. I wonder where they got the idea for that particular API from. Just putting that out there. And so I think Matlab is a great tool, and it plays nicely with many other people in the ecosystem. And I'm going to stop now because this has turned into a sales pitch, right?
Thank you, Mike. I think you raised a very good point there, though, that you don't have to move away from the spreadsheet. And I wonder if we could come back to Lucy on this, because that is the point. A lot of people will be using spreadsheets. And even if you decide to go beyond it, it doesn't mean that everybody will come with you, and they'll be perfectly justified in doing that. Lucy, do you have any thoughts?
Yeah, I think that's a really important thing to remember as well, to consider that whilst I'm really interested in learning to code, one of the things that is most important for me is that, does it actually offer me any solutions? I can't necessarily collaborate with my colleagues, because then we've all got to learn how to do this. It's, for me, spreadsheets are very quickly shared. They're very quickly used by multiple people. We all understand them. We don't need to learn that special language to be able to use them. And that's a real plus for me. It's also the time to learn. If I haven't got time to learn, my colleagues don't have time to learn, and it'd be another ask. And so for my purposes, that being able to just share, collaborate in real time and all this kind of good stuff makes it a very attractive research option for me. And the type of research I do, I think is key there too.
I think that's a very good point. And I realize that we are also drawing very close to our time, but I like the idea of closing that particular question on actually a defense for spreadsheets. Clive, did you have something quick to add?
Just very quickly, I mean, since we are plugging things, one of the advantages of using notebooks for writing code, I'm not going to mention any particular notebook, is that this does make it easier to share with your less experienced colleagues, because they can see the text descriptions, they can run the code, they don't need to know anything about it, and then they can start to dabble. You know, you can set it up so they can make little changes, they can change inputs, they can see how that affects the outputs, they can produce graphs. So there are ways of interacting with your colleagues that do not require them just to open a .mat or a .py and run it. There are more user-friendly ways to do that.
No, that's great, thank you. And whilst we're all plugging things, I would like to point out there's a whole other week of this research software camp and beyond the spreadsheet, so please do keep an eye on the SSI's website for the other events. Some of the panelists will be speaking at that time. We're actually out of time, but I was hoping that I'd be able to finish by just quickly asking each of the panelists a question that has often bugged me, which is basically when you started coding, or when you started thinking about what you were going to do after you moved away from spreadsheets, what was the one bit of advice that you wish you'd received at that time? And I'll pick on people in no particular order here. I think maybe we'll move to Yanni first.
Sorry, Simon, I was answer a question in the chat. Can you please repeat? I'm sorry.
No worries at all. So basically, when you started to learn to code, what was the bit of advice you wish you'd received at that time?
Oh, I started to learn to code really of young age. I was really smart. I come from the computer science world, so I actually code since I have 6. So I started as a play, but coding for doing research, I will post a tweet that I answered to Greg Wilson when he asked something like that, and I actually has to do with this. I say, I will like someone tell me that 90% of the data I was working come from a spreadsheet, and the other 10% are going to end in a spreadsheet. Because when we were talking in the chat was, I don't think we are going to replace a spreadsheet. There is no need to replace. I think we have to include in our pipeline, and perhaps some part of our workflow can end up in a package. When we build package of art in my work, actually we use it for what more say, for document and for formalize a process. And when you did the code, it's like an excuse to actually formalize how we work, which are the steps and which person do what part of that work. And sometimes we bring all these to the process, the analysis, but the data or is in a database and most of the time end in a spreadsheet, because it's what the rest of the world are using. So, and it's not bad, it's not wrong.
So regardless of learning to code, remember that code, your results will end up in a spreadsheet quite frequently.
Yeah.
Peter.
Okay, I think something that took me a long time to realize is that you should treat your code as a sort of a living organism, in that it changes and it responds to the environment. It responds to what you do with it. It grows, and you shouldn't be afraid to go back and make changes and work on things and improve them.
Thank you. More.
You shouldn't code alone. You should always ask to review, because you can never have like the perfect code. So like, don't get stressed if you haven't found an answer. Like, ask a question and like make it something more collaborative. Like it's not like the movies. I hope when you see a lot of people coding alone, most of the people that I coded with are organisms together, different organisms than what Peter said, but like people working together. So just remember that. Don't be shy.
It's a good point. It's not safe to go alone. Okay, so and Lucy.
Sorry, I mislaid my mute button. I say as a primarily a spreadsheet user, I think what I wish I'd learnt perhaps very, very early on is how unstable they can be and how careful you need to be. And really, there's some of those limitations can be a strength, because when you're super careful, you're doing sort of some more different types of research while you're doing it. But to be very, very careful. I've lost an awful lot of data over the years, and it's never pretty and it's never fun. So being very careful, I think, would be my my point there.
Careful with your data, I can agree with
Yes.
that. Lucia.
Being someone that had to rewrite her whole PhD code, comment the hell out of it, because you will forget what you were trying to do, and you will arrive to a point where it's just faster to rewrite the code than try to understand what the hell you were trying to do. So really, really, really comment everything. And second place, do not call variable 1, 2, and 3. No matter how in a rush you are, no matter how on a time crunch you are, always use sensible and not repetitive name for the variable, because you are going to overwrite them.
You're going to be telling people not to call their counters counter next. Jack.
Yeah, I would just say when I started it, I found it really intimidating, starting programming communities, full of really passionate people. There's lots of terminology. You can think everyone knows everything and I know nothing. But quite often everyone is just making it up. And so I would say really just get stuck in and don't be afraid to ask questions or reach out for help.
We're all imposters. And finally, Clive. Oh, I think you may be muted again. Clive's actually been told not to turn off his mute.
There we go. I thought so. Oh, anyway, no matter. I thought so. Sorry. What I was going to say is that most of these things are things I wish I was thinking about yesterday, not just when I started, because it's very easy to forget. But what I would say is think about what you want to do before you start hacking at your keyboard, because often you can start writing code, and especially with use of variables, in such a way that it's actually, as you get halfway through, you think, I wish I'd done things differently. And so of course, your code will change over time, and it is organic, as Peter said, but at least have an idea of where you want to end up before you start.
Fantastic. So I realize we're a few minutes over, so thank you to the panelists for coming along and sticking with us as we went slightly over the deadline. I just wanted to say thank you again for your expertise. That's been an absolutely fascinating discussion for me, and I hope that all our participants felt the same way. Thank you also to the participants for coming along and for all the questions. And I think with that, we can bring this panel to a close and say goodbye. Thank you.